Hey guys, what's going on? So I kind of want to show you guys a pretty cool property in my opinion of trig functions. So a lot of you guys probably know how to find the amplitude of individual trig functions. Like you guys know that the amplitude of a times sine of x, this is a, and the amplitude of b times cosine of x, this is just equal to b. I'm pretty sure most people know that. And this observation leads to an interesting question, right? What is the amplitude of this function f if we define f as a times sine of x plus b times cosine of x? What is the amplitude of this? And well, this is very hard, maybe even impossibly hard to do, unless we're able to rewrite this expression as one trig function, right? If you can write this as one trig function in terms of only sine of x or in terms of only cosine of x, then we can just use this property and easily find out the amplitude of this. So here's what we're going to do. We're going to make the observation, right? Sine of x plus y is equal to sine of x times cosine of y plus sine of y times cosine of x. All right, we know this. This is a commonly known identity. And well, here's the thing. These two expressions look pretty similar if you look closely, because we have a sine of x here, sine of x here, cosine of x here, cosine of x here. So if we're able to make a substitution where cosine of y is equal to a and sine of y is equal to b, we're going to be able to rewrite this as one trig function and then solve using these. But we actually can't make this a substitution straight up. What we'll have to do first is we need to make sure that a and b are in the range of sine of x and cosine of x. We need to make sure that they're between -1 and 1. And what we can do is we can multiply it by a constant. Okay? We're going to multiply both sides of this by a constant k, where k is obviously non-zero. And then we get this, right? And now we're going to assume after we multiply a and b by k, a and b are now in the range of sine of x and cosine of x. So what we can do is now we can make the substitution, right? We're going to let cosine of y be equal to ka and sine of y to be equal to kb. If you look over here, we want to turn this equation into this, right? So we're just substituting these two values in. If this is the case, we can actually solve for k, because actually at the moment we don't know what k are. A and b here are constants, but we don't know what k is. So we have to solve for k. So we can use the Pythagorean identity, which states that sine squared y is equal to cosine squared y plus cosine squared y is equal to 1. We make these substitutions to get k squared a squared plus k squared b squared is equal to 1. We can do some pre-algebra here to find that k is 1 over the square root of a squared plus b squared. All right. So now we know that 1 over square root of a... Well, actually, let's write this down again. So we have this. K times f of x is equal to ka times sine of x plus kb times cosine of x. Right? But now let's make these substitutions, okay? We have k times f of x. What did we say Ka was equal to? Ka was equal to cosine of y. And now we have a sine of x here. And then what do we say Kb is equal to? What do we say Kb is equal to? We said that Kb was equal to sine of y. And now let's substitute this value of k over here. So now we have found this. And because of the angle sum identity, we can just easily simplify this as sine of x plus y. And now we can rewrite f of x as square root of a squared plus b squared times sine of x plus y. And based off this observation, this commonly known fact, we can now find the amplitude of f as square root of a squared plus b squared. So now we know when we have f of x written as the sum of sine of x and cosine of x, where a and b are scaling constants, we know that the amplitude of f of x is just simply square root of a squared plus b squared. I find that to be a really interesting observation. A really interesting result of just applying some basic trig identities. I hope you enjoyed this video, and make sure to like, share, and subscribe. If you're interested in Terraria videos, I have a series about Terraria on my YouTube channel. You should probably go check that out.